Very good. Last week we were talking about the template class. We created a template class for an array, and we used it in two different forms um, for int and the for float, the same type of the same template. And I think Sebastian was meant to ask this, like, do we put type name here or class? If that was the question, I didn't understand. It makes no difference, Sebastian. These are actually the type name, if you're there, and everybody, uh, type name, if I run this with type name in the definition of the template, for the type I put type name and we run this, and hopefully it will run. Takes forever. So we have the array of of doubles here, perfectly fine. This is what we saw last week. And if I change this type name to class, there'll be no change. These can be really used interchangeably. And with class, you see that the result is the same. But why do we have two things? First of all, this is your style. You can choose to use class or type name. There's no difference. Uh, in the final assessment also, if you face such a thing, there are two identical things in the scope of what we have discussed so far. Type name and class are the same thing, you can use interchangeably. But in more advanced C++ courses or topics that you will have, probably you will face smart pointers that are kind of there to for um, memory protection and doing things better. You will see there are some topics that these two cannot be used interchangeably, but that's really out of scope of what we have discussed here in this course. So just keep in mind, class and type name can be interchangeably used as far as OOP244 is concerned. Um, what else I wanted to show? Yeah, another thing. Uh, Probably you know it. It's very intuitive, but I wanted to also show to you since in workshop 10 you're asked to implement such a thing. Um, Obviously, we can have for functions. If we have a function that accepts more than one argument, n arguments, n not equal to 1, n more than 1, uh, we can have different placeholders for the type of the inputs and outputs that function has. Same is true for the class. So you can have as many placeholders as you need in a template. Um, and it's very intuitive, but I just wanted to give you an example. So here, for instance, if I put the same sum function that we discussed, very familiar. Now the sum function accepts two inputs. The first one is type T1, the second one is type T2, and here I've defined one integer and one double. And I'm using sum, so this is type integer, this is type double. Obviously, what's happening here uh, is the addition of two types for in this very specific case. You just need to be careful not to pass values that cannot be added. So here, when I'm adding one integer to a float, depending on what output I'm expecting, either int will be casted to double or double will be casted to int. So here, when I say t, let's put this t2 as b. Let's put this t1 now for now. Now I'm expecting, and based on this, because the a is the first parameter I'm passing to this function, and the return type I'm expecting from this is t1. So this t1 is int. So this basically becomes int, and here whatever non-int this return sees, the compiler will automatically cast to int. So here this b, which is double, will be casted to int, and by casting that to int, only the integer part will be kept. So I'm expecting to see the result to be 10 plus 12, 22. So let's see if we have this. The result is 22. Now if I go ahead here and change this to T2, because now in this template, based on this template and what I have here, the compiler understands that the return type is T2, and this T2 here is double for the second argument, and this casts whatever it sees which is not double, it casts that to double. Obviously, if it is something that can be casted. So here, if I run this, we will see uh, all the int here. Int is casted to double, and the result will be will have decimal point. What happened to my computer? Successful. Oh, did I run out of space on my disk? Yeah, here. So the result is now casted to double. So this gives you a significant amount of flexibility when you are defining your templates. You can use as many types as you need for the input, and obviously just one type for the output, whatever it is. But again, you can play with that output type to get your desired um, output type. Um, yeah, just this simple example giving you a heads up. You can use as many types as you need with these templates. And that class and type name thingy that we discussed. Okay, this basically concludes. Let me see. Final exam is scary. Sebastian says final exam is scary. 30%. Guys, let me tell you something. For those of you who have really attended the lectures, and or not, you didn't attend, but you watched the videos carefully, all the concepts, at least for the second half, I can assure you all the concepts that you will face, all the uh, all the points that you needed to know uh, to excel your final exam has been discussed. And for the first half, since I know how Farda teaches, he has done his part also amazingly, and he has taught you everything you needed for this. So don't consider on that 30% of the portion of the final assessment, but focus on significant amount of knowledge that you have now, and you have practiced everything, every single concept multiple times through workshops. You have reviewed them for quizzes, um, and you have done for the like you have done the you're doing the final project. So it it is really just you don't need anything. You just review things, and this will be easy peasy. And by the way, for final exam is a little. I'm not saying this to. It's probably not good to say, because you should really go and study and review whatever you've learned so far. But final exam is, I guess, is a little bit easier than midterm exam. So you just need to concentrate, uh, and everything should be okay. So don't worry. The second half of the semester will have a higher weight in the final exam. So the questions you will see, um, you really need to know the things that have been discussed during the second half of the semester, starting from we've discussed so many things. So yeah, don't worry about that. Don't worry at all. Um, Very good. Is there any question? Okay, great. Before we start reviewing polymorphism, which will be a very short discussion, uh, I just wanted to let you know that I uploaded grades for milestone 1, 2, 3, plus your workshop 8 and workshop 9. So the only things that are left now are workshop 10, milestone 4, and milestone 5, which I will wait for the deadline to pass, and I will start grading. If you don't see your if you have submitted but you don't see your mark for workshop 8, 9, milestone 1, 2, and 3, message me, please. Okay, great. Uh, great. Let me see what I have here. Okay, let's open a notepad. Notepad plus plus. And review of polymorphism is actually, also I can close this. The review of polymorphism. It didn't open anything. Notepad. Okay. For object-oriented programming had three pillars, and one of the most important pillars was polymorphism, which is uh, which is having doing the same thing in different ways as we learned it. So now we want to uh, put whatever we have seen that had a flavor of polymorphism so far uh, in categories to be able to really look at them better, and to understand what polymorphism was that we have done so far. So historically, if you look at your notes, you will see a history, first like half a page's history. But if we want to summarize everything, we have two kind of polymorphism. Uh, Version 1 is a shallow is a shallow version, really. Uh, and if you look closer, the polymorphism, the polymorphism will pale. This one is called ad hoc. Again, where this name is coming from, it's history. You can take a look at notes. But in the ad hoc polymorphism, uh, essentially what we have is looks like it is polymorphism, but if you take a closer look and see what compilers are doing with the things that we think is polymorphism, you will see that it's really not polymorphism, and we don't really do the exact same thing in different ways. This ad hoc polymorphism itself is divided into two categories. One of them is uh, coer- coercion. One of them is coercion. Coercion is uh, what it literally is the casting. When you're trying to when basically the compiler has to change some type of what you are using to make it possible. For instance, in I just showed you an example of sum, and in this sum we said int 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 a double b, right? We said int a double b, uh, and let's define another one. And then we said that C is the sum of, well, not sum, like let's say A plus B, just directly say it. We said this is polymorphism. Why? Because now uh, A A which is int, is getting added to B, which is double. And now I can have another int d, and I can simply say c is equal to a plus d. Now here in this one, I'm adding an integer. I'm adding two integers and storing that in a double. Here, I'm adding an integer to a double, storing in that integer, and I can have, obviously, C equal to two doubles, for example, B plus B, B plus B, or B plus C, right? So this looks like a polymorphism. Why? Because now we have one action, which is adding, but three different forms. Addition is just one action, but you can add an integer to a double, you can add an integer to an integer, store in a double, and you can add double to a double and store in a function, in a double. So the the action is just one, but in different forms. So because we have one action and different ways of doing this, um, this looks like a polymorphism. But if you go down deep there, see what the compiler is doing here, the compiler is adding, not really, not really adding an integer to a double. It's not really doing this because it's impossible. Uh, we have 4 bytes for an integer, we have 8 bytes for a double, Actually, it depends on different platforms, but they're in. If you look at them, they are completely different entities. It's apple and orange, apples and oranges. You cannot add them. But what the compiler is doing is actually it is first uh, casting or converting int to double, and then adding double to double, right? This is what is happening behind the scene. So if I look closer, I will see this is happening. Uh, for instance, this action, if you were able to see the CPU, you could see that all these actions are taking place in the FPU, floating point unit of the CPU. That means these are all the same thing. And because of this trick that the compiler is doing and we're not aware, uh, and you have to look closer to see this, we see different forms. But in fact, all of these are uh, finally convert the int converted to double, and then the real action takes place over there. Um, that's why this kind of polymorphism is categorized under coercion, which is really the casting. You're forcing something to look like something else. The compiler forces the int to look like double so that it can add that to a double. And this is not really polymorphism. Because of this trick of the compiler, we think it is polymorphism. Uh, is this okay? Does this make sense to you? Okay, very good. Now, this shallow kind of polymorphism has also another uh, another subcategory called overloading. And we have seen this overloading many times. You have overloaded multiple different functions so far, and we really know the concept. So uh, let's again use the sum example because this is very handy and useful. If I say double sum, double A, and double B, uh, and overload the same function, say sum, this time using int a and int b, right? Now I have two functions, but the basically I have one action, addition, and I have one name for that. The name is sum, and in each of these I am adding in two different forms. That's why it looks like polymorphism. Addition as an action has been done in two different forms, form double and form int. Now again, this is not a real polymorphism because if you look at the behind the scenes of what the compiler is doing, the compiler is generating uh, two different functions, probably calling the first one sum double and calling the second function sum what sum int, for instance. So it literally generates two different function names with different names, two different functions with two different names, depending on the type of the argument and depending on the type of the output that it sees. So uh, if you had another function, sum here, for instance, if you had int sum double double, again uh, this looks like that we have the same function, but again for the compiler maybe created uh, I double, something like this. I don't know. It can, like, these are examples. Compiler generates a third completely different function with a different name for the function that had the same name, and we said this is, oh, this is amazing, this is polymorphism. Now we can have one function name, but depending on the input argument types and output type, we can use them, and the compiler is smart enough to recognize this and uses the every time it chooses the correct function. Well, yeah, it is true, but behind the scenes, it first generates at the compile time. It generates different functions for each of these different for all of these functions that look same to us, look the same to us. So overloading is the second category and is a shallow version of polymorphism. Now we have that probably we can call it deep version of polymorphism. And be ready, I'm gonna ask you if you can think of some real deep polymorphism stuff. Polymorphism. It is really um, doing one thing, one action in different ways. Can you think of any real polymorphism cases? Let me see, where's my mouse? Okay, here. Can anybody give an example of real polymorphism? Some polymorphism that the compiler, there is no compiler's trick involved, and it's really doing one thing, and the compiler is smart enough to pick the correct form of doing that.
Templates.
Sebastian, sorry, again, please.
Templates.
Exactly. Yes. Templates is, yes, exactly. Templates is the basically the is the is what this polymorphism really the real polymorphism is materialized in this template. Why? In templates, uh, you don't have any uh, action, and it's just a form, one form, and the different type of actions is generated from this single same template. So that is category number one. So we call it parametric polymorphism, which is exactly using templates. Uh, and we have seen this, how we can use templates. You create one template and you use it a million times with different types, uh, and every time the compiler knows what to do, and there is no trick involved. Another form, thank you, Sebastian. Another form is actually we have also seen this at the very beginning of the semester, and this was when we were using virtual functions, and this is called inclusion. Uh, in inclusion, we in the virtual functions, when we use the example can be virtual functions. In virtual functions, we saw the examples. I'm giving another example here. Like if we had a car, a class car, and this class car had a had a member function to display, uh, and that member function was virtual void display display constant, right? This was this, and if we had another class derived from this, let's say class EV, because I like electric vehicles, uh, EV that inherits basically from class car, public public car. It inherited from public car, and we if we created this, and again this also had a public member function to show the display constant. And by the way, I can also put virtual here with no problem, right? Even if there is no class is going to be derived from EV, I'm putting virtual. There's no problem, just in case if somebody wants to derive anything. And if I come down here, we did this with cat and dog and pet and stuff like that. And now, if I create a car pointer C and say new car, and then down here come and say now C. I want to display this. I want to display this car, and at the same time, I come down here and say car pointer D is equal to new EV this time, huh? Uh, EV this time, and do the exact same thing. D display. This would be a real polymorphism. Why? If you look at this, if just take a closer look at this. What is C? C is a car pointer, right? From the compiler point of view, when you look at this line and this line, you see that the compiler sees that this is a car pointer and it's calling display. Again, here, D is a car pointer and it's calling display. Huh. But we know that this display must display an EV, and this display must display a car. And this is the real polymorphism implemented into C++ and other object-oriented programming languages. How does the compiler know which display to choose? It's really smartly done behind the scenes, and there is no track here. So the compiler is really exactly what it is doing the action of car pointer calls a display function here, and the same thing, a car pointer calls a display function, exact same name, exact same arguments. There's no input argument, nothing. These two are identical in their nature, in their structure. The only difference that it makes is that the compiler knows now this there is a EV stored in this car pointer, and here a car is stored, in the car pointer, and based on that it knows there should be a difference, and it goes and calls two different displays. And this virtuality and this virtual functions uh, is also a very deep version of polymorphism. uh, and as Sebastian said, templates are the final version of that's the next stage of polymorphism, and this is all we have for the polymorphism. So two categories, a shallow one and a deep one, and in the shallow one we have coercion and overloading, and in the deep one we have inclusion and parametric. So these templates are very powerful. We have templates already very efficiently implemented for us uh, in this course, because you were learning things, like we were seeing everything for the first time. We had to implement those things uh, manually, but in the future, working programming in this C++ language is will be much easier once you know there is in the standard library there is a template for everything, and you can go there and just take a look at the template and read the documentation. Once you know what the documentation requires your classes or things to have, then you can easily go ahead and use those templates. Uh, and yeah, that's it. That's more or less what we wanted to discuss about polymorphism. The rest is just history. If you take a look at the note, it is really history lessons there, how it involved, who did what, and things like that. That I don't think are interesting for you. Is there any questions so far? Okay, I will post this. I will post this. And now, uh, let's take a look at our final assessment things that we will have. Uh, the format is similar to what you had in the midterm. The first part is the warm up part. Uh, and this is multiple choice questions. You will have somewhere between 12 to 15 multiple choice questions. Uh, you don't need to take notes or anything. I'll post this, but just letting you know. Um, and you will have 20 minutes to complete this multiple choice question. This multiple choice question is a selection from what you have had already in the quiz questions. If you did well in the quiz and you check the answers for those quiz questions, uh, you already have 20% of your final assessment. Easy peasy. There's no problem. So 20 minutes for 20% multiple choice question selected from the multiple choice questions that you've already answered throughout the semester. The next part will be two categories: debugging and walkthrough questions. Debugging questions are really piece of code, um, and you have to find a problem. So how? You will report three things. The first thing is in what line you see that problem. So it is the program has line numbers. You will say the problem is in line uh, blah blah, right? That will be one point. Then you will say what the problem is and what C rule is this breaking. Like in sorry, in C++, you have to like this should be this, but it's not, so it's breaking the rule, and this will bring compile time error, or it will cause runtime error, memory leak, stuff like that. And that will be 2 marks for that. And then you will suggest a solution. Say, okay, now the problem is this. Now, if we take this out, or we add this, or we like change this to this, then the problem will be solved. And that's another 2 points. So you just really need to go through the detail of the code that is shown to you, and find where the problem lies, what the problem is, and how you can solve that. This one will be 4 debugging questions. 2 of them are from first half of the semester. 2 of them are from the topics that we've discussed in the second half of the semester. 4 questions here. And then the second category is walkthrough. So you will see the code. The code is shown to you. There is no error in that code, and you will write the output of that code. So you will say, okay, now I see this is the code. Now in the main, okay, this one, this one, this one. Then the result will be this line, this line, this line, this line, and that will be the output of that code. And you will have 2 walkthrough questions like this. So 2 programs. You will need to find out the output of that program. This part overall, this is part 2, which was itself divided to 2 parts, and total time for this is 50 minutes. 15 minutes, and it's 40% of your total mark. 15 minutes and 40%. So basically you will deal with 6 questions. 4 of them are debug type, 2 of them are guess the output or walkthrough type questions. And the last one is coding part. You're not supposed to code everything from scratch. The code is given to you, but it's incomplete. And you will have to complete that code based on the instruction. This one is again 50 minutes, and it makes 40% of the final assessment. And I guess you will only have 1 question, 1 coding question. Let me see. Is it 1 or 2? I guess it will be 1 coding question. So this is the last part. And the exam will be, well, let's say assessment, will be available Sunday night, or 12 a.m. on Monday, August 15. Well, it's sometimes confusing. It's 12 a.m. Monday. It means Sunday night. It will be available from then, Sunday night, or Monday 12 a.m. August 15, until 11:59 p.m. Tuesday, August 16. So basically, it's open for 48 hours. Actually, 47 hours and 59 minutes. And you can attempt this midterm. This is a one-time attempt. You can attempt this during this time window anytime you want. And that's it. The answers are actually you will type the answers. So there's no snapshot, no image is accepted for your response. The box that you will type your response doesn't really allow you to put any image or a snapshot or anything like that there, so you have to type. uh, and overall you can see it's easy, I guess. You just need to concentrate, review things. You already know a lot of things. You just need to review, relax, and then take this assessment. That will be the about this assessment. Any questions about the final assessment?
Hamid, one question. You mentioned that each part had like a certain amount of time. Is this because each part is done separately, or is it just like one exam with like one combined time to submit?
Yeah, it is. I think I haven't implemented that on the Blackboard yet, but based on what we have discussed with other instructors, it's going to be a specific time allocated, as I said, for each of these parts. So you cannot use some parts time for other parts. Well, let's consider it will be like this, which 99% I'm sure. But if it is like, okay, go ahead now, you have 120 minutes for the whole exam. That's another story. I can put another announcement, but I'm sure it's not like that. So for each part, you will have that specific amount of time that I mentioned.
All right, thank you. Yeah, that's good. That's
Yeah,
I think I actually use better.
great, very good. What else? Any questions? If there is no question, there is nothing left that we can discuss. Next week we will not have lectures. And let me see public chat. Oops, that's clear. Great. Very good. Just I will be available as usual on Microsoft Teams. So if something comes up, let me know, and we can discuss. But it's just use time. There is no quiz, nothing, everything finished. Just workshop 10, which many of you have already submitted, and milestone 5. That's it. We are done with this course. One last thing, if you don't have any question, just wanted, because this was my first semester teaching OOP244. So just wanted to know your opinion, your suggestion, anything. I anything from like uh, I can take anything, any suggestion. Don't worry at all about it. So be honest. Uh, Give me feedback, whatever was good, whatever was bad. I will use this for my future classes, please. And since I guess the some of the best students are here, so I guess the feedback will be useful. Please feel free to talk whatever you want to say.
I actually liked it. I had one question. Are you
Mhm.
gonna be teaching next semester for OP? I think it's 345, 344 something.
I will not because the because I will be working in industry. I found an R&D position, which was good, which was good news. Uh, that I asked Seneca to see if they can give me some class that is virtual or is like in the afternoon after 5 o'clock, after 5:30, but they said there is no option like that, and all the classes will be in person, and there is no option for any class after 5:30 or something like that. So unfortunately, I was willing to teach also this semester, but because my work will start and I don't know how that will go, I will be off next semester. But I will come back hopefully if the work allows me to work, and if Seneca agrees to give me some classes that can fit in my schedule, yeah, it will. I will be more than happy to come back. I'm also actually thinking about creating some YouTube videos, especially for those people who are interested in embedded systems. These days, there is a surge of embedded systems in everywhere from electric vehicles to many IoT devices, wearable devices. All these require you guys to be very good C and C++ programmers, so that you can program um, in the for different hardware. So there are many amazing microprocessors and microcontrollers out there that people are using for like amazing applications like VR, virtual reality. We see a lot of things are going on. So they all the last week I think Google also announced they are working on a version of programming language called Carbon, which is basically child of C++. And if you know C++, they also support C++. Is still C++ is the backbone of all the good things that we have in the world. And Carbon is based on that. So if you're good with C++, the Carbon will be just a 1 month work probably. You just need to review. And there is Roost, also very close to C++ plus some other features. So these are two other alternatives. Once you have built a solid foundation for your C++, and probably next semester you will expand this, especially for multi-threading. I emphasize on learning how to do multi-thread coding using C and C++, which both is possible, and learning some real-time, like you will have courses I guess for operating system, but learn real-time operating systems. There is a lot going on there for RTOS, different RTOS versions, free RTOS, and graphic modules that you can put on these microcontrollers. Good examples are like smart watches. You have Fitbit, you have Apple Watch. These are all amazing embedded system applications that are based on C++ and these real-time operating systems, which all of them fit into category of the embedded programming, embedded software programming. I'm thinking about posting videos, so if you like in the future, obviously it will not start quickly, but you can watch those. And well, the question was if I will.
I'd be interested in those videos, by the way.
Thank you. I will try to post occasionally these videos, and I hope that helps. By the way, if you're interested in this kind of things, you can simply purchase evaluation boards, which are cheap. Like you can find, I can give you different examples. Like you can buy from STM microelectronics. You can buy a board for like $10 and then start programming. Do amazing things. Home automation. You can automate things in your room and do robotics if you like. So yeah, the sky's the limit. A lot of amazing applications. Yeah, so we'll see what industry will bring to me and how it will go. But I really like to be in Seneca, especially when I see the students that are motivated students and hardworking students just like yourselves. Sorry, it was not probably the answer you were expecting. It's like the answer was 10 minutes. What else?
Can you hear me?
Yeah, Armando, I can hear you.
Um, I think just to add to it, like I maybe like, the random questions that you asked during the class kind of also keep you engaged. Yeah, that was
So
maybe
you
something
so you mean
you
you
wanted
I
to.
ask so you mean I ask more random questions during the class? That's your suggestion?
Yeah, why not? It definitely will help. And like you were saying, some of them were on or will be on the quiz, so it would definitely help to for everybody to have an extra reminder, I guess, a bit of reminder on concepts.
True, true. Yeah, we'll try to do that more. I like it because it makes it interactive, and it uh, after 15 minutes, 20 minutes, it happens to everybody. It's not just like in class. If you watch a video that somebody is just talking about something, no matter how amazing that stuff is, you get bored, and after like 20 minutes, your sensors are off. So that's a good way of making that interactive. I will try to do that more. Thank you so much. That's a $1 million suggestion. Thank you.
No problem.
And also there is another thing. I think Fadat did that, and I really like it.
Uh
It's like a bonus. It's like a bonus for
huh.
every correct answer.
Ah,
So
yeah,
basically, yeah. So it's
I know.
encourage the student to answer, and they get bonus for their midterm or final. So that was
True,
nice.
true. I should have done that. I know. Sometimes, especially some of you, you also did tram once. Sometimes when you're teaching, you're really thinking about how to explain the thing in the easiest possible way to students. So you're not really concentrated on the code, and you stuck somewhere that it's ridiculous. Like in when you're coding, it's obvious to you and you don't make that mistake. But when you're teaching or explaining, you try this, explain the code to your friend, and at the same time try to concentrate on the code. At least for me, I'm not that multitask, so it was difficult sometimes. The catches from the students were priceless. I remember you did that once. Many students did that during the semester to me, and yeah, next time I will do that. There must be a bonus for that. It was difficult for me to track who got that bonus, so that's why I didn't do that. But there should be like an Excel sheet or something so that you can input that, or ask the students to send you an email. I could do that. I'm sorry. But thank you for everybody's help to make an interactive and less faulty codes and sessions during the semester. I'll definitely do that next semester, Trent. Thank you.
You're welcome.
Okay, what else? Great. So I will post the codes and this one I'll push to our GitHub, and I wish you wonderful weekend, and feel free to text me on Teams if something comes up. Other than that, I think we've covered everything, and have a great weekend. Take care and bye.
Oh,
Take care.
I mean, I must have
Yep.
missed this, but we're having like a review class on Tuesday and Friday next one or next week,
Review for the materials.
or are we like, or what are we going to see next week's class? I think I might have missed it
Yeah,
if you
that's
mentioned it.
yeah. I mentioned there's no class because
Oh,
yeah, that's what I said. You go review, and whatever problem you have, you can bring that to me anytime. You can text me on Teams and we can discuss. But other than that, I don't have any specific thing to review because everything is recorded. You can watch the videos. Whatever I say is just redundant. So
okay.
yeah, there will be no official lecture class like this next week.
I see. All right. Thank you very much, and
Okay.
best of luck on your new job.
Thank you so much. You too, everybody. Okay, take care.
Have a good one, Professor. Take care.
Thank
Thank
you.
you.
Bye.